So today we'll learn the numericals of chapter 2, which is physical quantities and measurement, which basically deals with densities. So the first question, the density of air is 1.28 gram per liter. So that is density given. So you write given density equal to, we have 1.28 gram per liter. Express it in gram per centimeter cube and kg per meter cube. So solution lete hain. So we understand 1 gram per liter, 1000 gram per centimeter cube. Okay, so now what do we have here? So in general we have density will be 1.28 upon 1000 gram per centimeter cube. So if you're converting, so you write the formula, what is the conversion formula, and then you do the numerical part. So we have 0. Shift this part, 0.00128 gram per centimeter cube, which is easier. Now this is the A part. The B part, we already know that 1 gram per centimeter cube can be written as 1000 kg per meter cube. Or you can directly write 1 gram per liter is equal to kg per meter cube. So we have density is equal to 0. Now I'm taking this one, 128 gram per centimeter cube, and I'm converting this into 1000 times 0.00128. That is 1.28 kg per meter cube. And that's it. I hope you understand. Let's go to the next one. Second question, the dimension of a hall are 10 meter into 7 meter into 5 meter. If the density of air is 1.11 kg per meter cube, find the mass of the air in the hall. So basically we are given the dimension. So let's go for the dimension. So basically that is volume which is given. So we have 10 into 7 into 5. If you multiply, this is 350 meter cube. There are 3 m's. And of course we have the density of air, which is 1.11 kg per meter cube. So you need to find the mass. So obviously solution is density equal to mass upon volume. So basically what we are talking about is the density of air equal to mass of air upon the volume of the whole hall. We understand air covers the whole volume. So we have 1.11, which is equal to mass and 350. So we multiply this, we get mass is equal to 350 into 1.1. When you multiply this, you get 388.5 kg. You can multiply easily at the side, at the right side. So I hope you understood. You write the formula, put the value, multiply, and then you get the answer. When you get the answer, make sure you're writing the unit properly. Let's go to the next one. The third question. Okay. So now we have the third one. The third one is the density of aluminium is 2.7 gram per centimeter cube. Express it in kg per meter cube. So that is again easy. So we have density of aluminium, you can write AL if you want. We have 2.7 gram per centimeter cube. You have to find it in SI unit. So you have to find it in SI unit. So we have density. We know the conversion, So since we know 1 gram per centimeter cube is 1000 times kg per meter cube. Okay, so once you write the conversion, then you write density is equal to 2.7 into 1000, and you write the unit as well. Then you convert this, which is 2700 kg per meter cube, and that's your answer for aluminium in SI unit. Easy. Let's go to the next one. Now we'll go for the fourth one. Let's write it 4 here. The density of alcohol is 600 kg per meter cube. Always observe what is the unit of your given part. Express it in gram per centimeter cube. So the opposite one. Since we know, so we can write 1 kg per meter cube is 1 upon 1000. 1 upon 1000 gram per centimeter cube. So we have density is equal to of alcohol is equal to 600 divided by 1000 and convert directly gram per centimeter cube. You can cancel this and we have 0.6 gram per centimeter cube. Sometimes they will ask you whether this will float above water, so you can write yes because the density of water is 1 and this is less than 1, so it will float. I hope you got it. Let's go to the next one. Fifth, a pair of zinc of mass. The mass of zinc is given. Let's say I'm writing this way. We have 438.6 gram. Okay, as a volume of, okay, volume is given in CGS as well, 86 centimeter cube. Find the density of zinc. Now, sometimes they will ask you to find the density of the zinc as well as they will ask you to convert it into SI units. So simple. So you can write density. We know density is equal to mass by volume. So we have density is equal to mass 438.6 upon 86. And if you divide this part with 86, let's divide this one. 438.6. Directly you can divide it by 86. So 86, we know that 86 ka half is 43. So 5 is 430. So we have an 8. It's a point. So take a point over here. 6 drop here. We have answer 86. Easy calculation. So we have 5.1. Now it should come in what unit? The mass is given in grams, so you write gram. The volume is given in centimeter cube. Now remember, if the volume is not, or mass or volume is not given in the same unit, you need to convert it into same unit. Okay, once you get this one, if they want you to convert it into SI, multiply by 1000. So yes, the density of zinc is 5.1 gram per centimeter cube. I hope you got it. And make sure whenever you're practicing numericals, you're writing the calculation on the rough side on the same page for calculation. Show the calculation and that will boost your confidence as well. Let's go to the next one. Now we have 6th. So 6th question. A piece of wood of mass 150 grams. So let's understand we have mass of wood. So let's say I'm writing W. 150 gram, which is in CGS unit, and has a volume of 200. So we have the volume, which is again in CGS unit. Very good. Find the density of wood in CGS and then SI, like I was saying. So let's go for the solution. So okay, we have density is equal to mass upon volume. So we have 150 divided by 200, which is 3 by 4. 3 by 4 is 0.75. 0.75 gram per centimeter cube. This is in, so you can write density of wood in CGS. You can write like this. CGS, the density of wood is 0.75 gram per centimeter cube. And in SI, you know, density would be 0.75 into 1000 kg per meter cube. Now for the safer side, you don't want your teacher to cut your marks, so you write 1 gram per centimeter cube is 1000 times kg per meter cube. Make sure you're writing the conversion. So we got 750 kg per meter cube. Sorted. I hope you like that. Easy. Let's go to the next one. 7. Calculate the volume of wood of mass. Okay, so the mass of the wood is given. Again, we have 6000 kg. Now this time it is given in SI. And if the density is given in 0.8, okay, now density is given in CGS unit. So 0.8 gram per centimeter cube. The best part would be to convert any one. So we understand 6000 multiplied by 1000 will be a big number. So I'm converting the density. So let's first we'll go for converting. You don't have to write this line. Let's say you got D D will be equal to 0.8 into 1000 kg per meter cube. Why I'm doing this? Because the mass is given in kg. Make sure you write the conversion as well. Gram per centimeter cube is 1000 kg per meter cube. So now we have 800 kg per meter cube. Now we can write, now we know density is equal to mass upon volume. Now put all the values which are in the same unit. Therefore, we have 800 kg per meter cube. You can write that also if you want. Mass is given as 6000 kg and volume is not given. So you can take volume here. We have 6000 divided by 800. So if you see this case, we have kg per meter cube. So this meter cube will go up, kg will get cancelled. This is how we calculate the value. Okay, and the answer comes to be 7.5. So density of wood is 7.5 meter. Sorry, not density. Sorry. So the volume comes to be 7.5 meter cube. Make sure you're writing the unit properly. Okay, let's go to the next one. 8. Now we have the calculate the density of a solid from the following data. Okay, in this case, we would need the other side of the page. So I'm bringing this one. I hope you can see this one. No, okay, sorry. Okay, so calculate the density of a solid from the following data. We got mass of solid. So we have M 72 gram, which is in CGS. Initial volume, so let's write it as V1 24 ml. Again, remember ml is in CGS. Final volume, let's say V2, it is 42 ml. Okay, we have to find the density. So let's go for this one. So for density, we need single volume. So in that case, we can understand volume of solid. We have V2 minus V1 coming from the measurement technique, also called as the displacement technique. So we have 42 minus 24. And that comes out to, okay, we have 8 and we have 18 ml. Now we know that 1 ml is directly equal to 1 centimeter cube. So I'm converting directly because it's a solid. So I'm taking it directly 18 centimeter cube. All good. Let's go to the next one. Now the next part, density equal to mass upon volume. Now we already know mass in 72 upon 18, 4s, that is gram per centimeter cube. I hope you understood. It was easy. Let's go to the next one. 9th, the mass of an empty density bottle. Now this is related to density bottle experiment. So let's go for this one. The mass of an empty density bottle is, okay, so we take M1 as empty bottle mass, or you can say mass of, let's take it as 21.8 gram. Okay, let me just use this one as well. Okay, now we have M2, which is, I'm writing directly, we have the when filled with water. So basically this is bottle plus water mass. So don't worry, the English is not that important over here. Okay, then we have M3, which is bottle plus the another liquid. Mass is 40.6. Okay, so we have to find first the volume of the density bottle, second the relative density of the liquid. Okay, so basically first we'll say volume of density bottle. So the first thing that you should do in this case, or in the density bottle one, is to find out the mass of water and the liquid. So we have mass of water is M2 minus M1. Of course, bottle plus water minus bottle will be the water. Okay, so we have 41.8 minus 21.8, and that would be 20 gram. That is the mass of water. So now we know that in order to find the volume of the bottle, we will use density of water is equal to mass of water upon volume of density bottle. I hope that is okay. Now once you find this one, let me just adjust this for a while. Okay, so now we know the density of water is 1 gram per centimeter cube, which is equal to 20 upon volume. So volume is 20. You take the volume here, divide 20 by 1, and that is 20 centimeter cube. Therefore, volume of density bottle is 20 centimeter cube. Sorted. That's your first one. Let's go for the second part. You have to find the density of the liquid. Okay, for that case, what I'm doing is I'm erasing a small part of this part. Please, at any point, if you find anything difficult, pause it and you can record it, or you can go back and read it. If there's any problem, you can write it in the comment section. Okay, let's go for the B part. So B part, you have to find the density of liquid. Now there's a very beautiful formula already given. We have to find density of liquid is, we have the mass of liquid, that is M3 minus M1 upon the mass of water. Now that is 40.6 minus 21.8 upon 41.8 minus 21.8. Now whenever there's a confusion here, make sure you do the calculation alongside. So a lot of people will make a mistake over here only. So we got 16 plus 8 here, we have 8. This is 9 by the way, okay? So we got 9 minus 8 is 8. I hope you're getting it. Okay, and this is 3. So this is 18.8. So we have 18.8 upon 20. So if you take the 0, we have 1.88 divided by 10, you get this. And then you divide this, we have 0.94 gram per centimeter cube. So if we cut this one, so we have 0.9 size 18, and then we have 4. Okay, so this is the density of liquid. Now if they ask you what is the relative density, just take out that G by centimeter cube. That's it, done. So that we will see in the next question. So anywhere, if you felt that I went a little fast, you can go, you can change the speed of the video, as well as if you have any doubt, make sure you write to me directly, either in the comment or you can WhatsApp me. Let's go to the next one. Now the 10th question. Again, a similar type. Let's go for this one. Now, given. So I'm writing given over this one. So let's read it. From the following observation, calculate the density and relative density of a brine solution. A brine solution is basically water plus salt. Please remember. Okay. Just general knowledge. Okay, so we have M1. So mass of empty bottle is taken as M1. So we can take it as M2, M1. Bottle plus water is taken as M2, 50 gram. And mass of bottle plus brine solution is, basically we'll take the brine solution as the liquid. So we got 54 gram. Okay, easy. So now solution. So first of all, we'll find the mass. So we have mass of water. First nikalo, mass of, I think they're not asking us to find the density of the bottle, so we can directly switch. From the following, calculate the density and relative density of a brine solution. So directly we can go for density of brine solution. We have This one we have M3 minus M1. Make sure you understand. It is the liquid minus the bottle, then the liquid plus water minus the bottle. The reason is, if you are finding the density of the brine solution, the mass of the brine solution should be up. Okay, M2 minus M1. So put the value here, 54 minus 22 upon 50 minus 22. Make sure you're not doing any calculation. Don't cut 22 directly. Okay, so we got this is 32 upon this is 28. Okay, and then when you cut this, you get the value. Let's say 4 sevens, 4 8s, and then you can cut it like 1.14 gram per centimeter. That's the density of the brine solution. Now, if they ask you the relative density, just take out the same. We have the relative density, you have the same formula. So RD of brine solution would be same number. Let me just write it somewhere else. So solution is same thing, same density. Okay, so we got 1.14. That's it. We are not writing the unit because RD does not have unit. That's it. That's your answer. I hope you understood. Let's go to the next part and the last part probably. Yeah. So now we have the mass of an empty density bottle, almost the same thing given. Okay, so given we have mass of empty bottle is 30 gram. It is 70 gram when filled with water. Okay, so we got M2, which is bottle plus water, 65, sorry, not 65, 75 gram, and 65 gram when filled with liquid. So a little English play, you can say, play of words here and there. That's it. Okay, so we have the same thing. We have to find the volume of density bottle. That is something that we used in 9th, and then the rest is what we did in 10th. So for that, let's go for this one. Solution. Okay, so we have density of water is equal to mass of water plus volume of density bottle. Okay. So this we already know, this 1 gram per centimeter cube. The mass of water will be M2 minus M1 upon volume. This is what we have to find. So let's write it as V. So take the V part here. We have M2, not M2, we have 75 minus 30 upon 1. So we got 45. Since we are talking about the volume of the bottle, let's take it as M. Or you can try it 45 centimeter cube, not an issue. Once you're done with this, this is the A part. Let's go to the next one. So you can stop and write the whole thing, and I'm doing it so that the video does not go to a long time. B part, we have density of liquid. Density of liquid, we have a very simple formula. We have M3 minus M1, which is the mass of the liquid upon the mass of water, basically comparing. So we have 65 minus 30 upon 75 minus 30. So in short, we have 35 upon 45. And that comes out to be, if you cancel it with 5, we have 7 by 9, and which is 0.77 gram per centimeter cube. That is the density of liquid. All good? Now, if they ask you to find the density of the RD of, so the RD, the relative density of liquid, is same number, 0.77 without a unit. Make sure you understand, without a unit. And that's it for the day. We have covered all the numericals from the textbook, and please feel free to share it with your friends as well, and keep practicing from this. And if you have any doubt, make sure you write to me. Thank you.